So welcome back to the continuation of our tutorial series on deploying a machine learning model on Kubernetes. So in this part, we'll be setting up the monitoring with Prometheus. So you'll be setting up Prometheus for monitoring and configuring the Prometheus to scrap the ML service matrices that we have defined earlier with our API service, like number of prediction requests sent to the model that we deployed, and we will be accessing the Prometheus dashboard, and we will explore a dashboard to see how it can be helps to monitor the life cycle of the ML model. This is for monitoring the performance and health of the ML service. So within Kubernetes environment. So Prometheus is an open source monitoring and alerting toolkit which is widely used to collect and store metrics in real time. So it can be configured to scrap metrics from various services running with the cluster, including our machine learning service. So visualize them through its web interface. And here in this setup, we use three primary Kubernetes resources. One is config map and deployment and service. So the config map holds the Prometheus configuration file, which specifies how and where Prometheus should collect matrices. And the deployment defines how Prometheus will run within Kubernetes, ensuring that the Prometheus container has access to the configuration and is exposed on the right ports. And finally, the service exposes Prometheus externally via a load balancer to allow the user to access the Prometheus UI and query the matrices. By deploying this manner, so you can effectively monitor the ML service health, resource usage, and other important matrices in real time. Like it will provide an insight that can drive the optimization or alert you for the potential issues. So this integration is very crucial for maintaining the reliability and performance of the machine learning model in production environment. So let me walk you through the YAML file here. So we have our API version 1. This specifies that API version being used for the config map is version 1, and kind config map just indicates that you are defining a config map which stores configuration data that can be shared with other resources like pod or deployment in Kubernetes. And then metadata. This section contains the name of the config map, which is Prometheus config here. And then data, this section holds the actual configuration data for Prometheus. So it includes a file called Prometheus YAML, which is the main configuration file for Prometheus. Global scrapping interval to 15 seconds, as Prometheus scraps matrices from the target services every 15 seconds. And then we will be having our scrap config, and this section defines the scrapping jobs for Prometheus to collect matrices from various sources. The job name you see here is ML service. This defines the name of the scrap job. We'll be seeing all this in the web interface of Prometheus later. And then we are having our static config. This specifies the target configuration, and we do have target, which is ML service 8000. The target for Prometheus is to scrap matrices from ML service on the port 8000. So the config map basically stores the configuration for Prometheus to scrap the /matrix endpoint from the ML service deployed in Kubernetes cluster. And now deployment. So you see the deployment do have the API version and stable version for managing the deployment in Kubernetes, and we have our kind deployment. So this specifies that you are creating a web deployment for Prometheus server, and deployment ensures that Prometheus runs as a set of ports and it manages their lifecycle scaling and updates. And we have our metadata. So this section, which contains the name of the deployment, which is Prometheus in our case, and then spec section. This is where you define the detailed configuration of the deployment. So we have our select or match labels. So this ensures that the ports created by these deployments are selected based on the app Prometheus label. And then templates. So this defines the ports template that will be used to create the Prometheus port, and metadata label app Prometheus. So this sets the label app Prometheus on the ports created by this template. And then we have the spec section. So this defines the containers to run in the pod, and name Prometheus, the name of the container, and the image like from Prometheus. So this specifies the Prometheus image to be used. So this is the official Prometheus container image from Docker Hub. And then we are having our port. The container exposes port to 9000, so which is the default port Prometheus listens to for web UI access and querying. And then we'll be having volume mount. So this mounts the config map as a volume inside the container, and the config volume is mounted to the path etc Prometheus here inside the Prometheus container, making the Prometheus YML configuration available for Prometheus to read. Okay, and finally we are having our volume section. So this defines the volume that will hold the Prometheus configuration. So config map name, this tells the Kubernetes to use Prometheus config map defined earlier and mount it into the container. So this section basically defines the Kubernetes deployment that runs the Prometheus server using the official Docker image from the Prometheus repository. So it ensures that Prometheus scraps the metrics from the ML service as defined in the config map. And finally, service. So as we saw like earlier, the API version is 1, and then kind, this indicates that you are defining a service in Kubernetes to expose the Prometheus service. And then metadata.name Prometheus, this sets the name of the service to Prometheus. And then specification, it just defines the configuration of the service, like select our app Prometheus. This tells the Kubernetes to select the ports that have the label app Prometheus, and then ensure that the service targets the Prometheus ports created by the deployment. And we'll be having the ports. It just defines the port configuration for the service, which is 9000. The service will be exposed to this port, so which is where the Prometheus will be accessible. And finally, we have our load balancer for the service. So this specifies the service should be exposed as a load balancer. If you are using a cloud provider like AWS, GCP, a load balancer service type will create an external IP that allows access to the Prometheus from outside the Kubernetes cluster. So this service exposes the Prometheus to the outside world. So if you are using a cloud provider with load balancer support, it ensures that like Prometheus can be accessed on port 9090. So this configuration, which allows Prometheus to scrap the metrics from our deployed service and provide access to Prometheus web interface for querying and visualizing the matrices. So now it's time to deploy the Prometheus services. For to do that, let's do kubectl apply. It's Prometheus YML. Okay, great. So let's open the Podman. So you see the Prometheus, it's deployed successfully. Let's do kubectl get. So once deployed, let's access the Prometheus dashboard. Okay, so for to do that, the same way that we have launched our application, let's launch the port forwarding with the service Prometheus to the port 9090 as we saw earlier. Yes, let's open the Prometheus dashboard. So let me go here to the target health. So we see our ML service metrics endpoint is up here. Okay, so if you see target, this is our endpoint that Prometheus is scrapping, as I said earlier. And we have last scrap. This shows when Prometheus last successfully collected the matrices from this target. And health, if you see, if everything is working fine, the health status should be stayed up in green. If it's down, Prometheus is having trouble scrapping data from the service. Scrap interval in our case is 15 seconds. For every 15 seconds, it will scrap and fetch the matrices from the target. So we are at the end of this part, and we are in the end-to-end tutorial on deploying a machine learning model on Kubernetes with auto scaling and monitoring. So far we have like see the overview of like how we can deploy the machine learning project with Kubernetes, and also we have build a model, machine learning model and API, and we have also containerized the model API with like Docker, I mean with Podman, and then we have also setting up the Kubernetes cluster, and we have deployed the ML services on Kubernetes. We have implemented the auto scaling with HPA, and then also we have set up the monitoring with Prometheus. So in the next part, we will be seeing a few other Kubernetes commands to like debug the deployment issues, and also we'll discussing about optimizing the resource allocation and scaling strategies.